a case where there is a block of 10 kg resting on a horizontal surface. Coefficient of friction between these two surfaces, that is mu is equal to 0.1, and there is a force of 20 root 2 Newton which is being applied at angle of 45 degree with the x-axis in the upward direction, and we are asked to find the value of this acceleration of 10 kg block. What is that value? So obviously, because the friction is there, the mu is given, so it means that there is going to be some friction force. When friction force is there, that certainly we have to somehow, we may have to use the value of limiting value of friction force. And the limiting value of friction force, we know that is F is equal to mu n. Limiting value, coefficient of friction into normal reaction. When 20 root 2 Newton is being applied over here, so what we can do is, so this is x-axis, this is y-axis, we can break this force along two axes. One is this way, the other is this way. This 20 root 2, so this is theta 45 degree, so this is cos component. This comes out 20 root 2 cos 45 degree, and this is 20 root 2 sin 45 degree. Now we know that is sin 45 degree is equal to 1 by root 2, also cos 45 degree is also equal to 1 by root 2. So when you put the value of 1 by root 2 over here, so this comes out to be 20 Newton. Same way, this will also come out to be 20 Newton. Whether you apply a single force or you apply its component, that's one and same thing. Now we have broken into components, so its job is done. We can remove this force because this force is now being represented by its components. So we have a 20 Newton force this way and 20 Newton force in this direction. We are asked what is the value of acceleration of this block. Now because there is a force in the upward direction, so the normal reaction will not be mg, normal reaction will not be 100 Newton. Let's see what happens to the normal reaction. If we draw the force diagram, Earth says I am going to apply a force of 100 Newton in the downward direction. Because of this pull by the Earth, this block pushes this surface in the downward direction, and this surface retorts back, applies a force n in the upward direction, or we can call it as n1 and n1. Let's focus on the block itself, not this lower surface, so let's remove this force. We are not bothered about it, it clutters the diagram. So over here, onto this block, that this will not moving in the y-axis. So as long as this force is less than the weight of the body, it will not be lifted up. Therefore, the acceleration along the y-axis we observe that is equal to 0. So it means summation of forces along y-axis is equal to 0. Net force along y-axis, it has to be equal to 0. It means the upward force, that is 20 Newton plus normal reaction, that is N1, should be equal to 100 Newton. So it means N1 should be equal to 100 minus 20, that is 80 Newton. So normal reaction now is 80 Newton, a component of this force. This way it has reduced the normal reaction. So when the normal reaction is altered, we know F is equal to mu n, limiting value of friction force is mu into n. So when the normal reaction is, the value of normal reaction is changed, certainly the maximum value or the limiting value of friction force, that will also be altered. So when it tries to move it this way, because this force, the block tries to move it this way, there are irregularities. So when there are the irregularities on the top, on the lower surface of this block on the top, will push the irregularities in the lower surface in this direction, and this will retort back. To every reaction there is equal and opposite reaction. So this limiting value of friction force is going to be mu into n, that it comes out to be mu is, let's calculate the limiting value. Mu is 0.1 into normal reaction. Normal reaction we have calculated 80 Newton. So it is 80, that is 8 Newton. So limiting value of this comes out to be 8 Newton. Now we see that this force is sufficient enough to overcome the maximum value of friction force. So it means this block will certainly move in this direction, this will accelerate in this direction. Had this force come out to be bigger than this force, then this would not have moved in this direction, it would not have accelerated in this direction. But in this case, 20 Newton is bigger than 8 Newton. So along the x-axis, if we say this force 20 Newton minus this force, along the x-axis we are observing what the forces. Now the forces along the y-axis, they have done their job. We are just interested along the x-axis. So this side forces minus this side forces, it is a resultant force, net force is equal to mass into acceleration, mass of this body only, 10 into A. So 12 is equal to 10A, and A comes out to be 1.2 meter per second square. This is the value of acceleration we get.